It's November 9th, 2025. I've stopped at this conglomerate bed. The dip here, a little hard to make out in this outcrop, the dip, but it's basically off to the right a little bit and pretty steep. We're in Upper Cretaceous deep water sediments here. We know they're deep water because of the microfauna that's found in the adjacent shale beds. This one's particularly pretty and very interesting on a couple of aspects. One is, you can see these things are really well rounded. There's my knife for scale. There's a quartzite stuff, a lot of quartzites in here. There's granite. There's a granitic rock there. There's some metavolcanics that I don't see one right now in here. But there's a whole array of stuff that a lot of this stuff is not local. And the story is, there's a gneiss there. And another one up here. Nice. And the depositional environment was, again, this was in the deep basin, but not far from the shoreline. We had probably a pretty narrow shelf, a delta coming out on the shelf, big river system to the east of that, going back into the terrain that's now eastern California, northwestern Arizona, possibly all down into Sonora, Mexico. And there was a series of big river systems. Of course, the mountains that are here today that I'm hiking in, they weren't around at that time. The mountains I'm in are, they're 2 or 3 million years old at the best. And so we had a big coastal plain going for a couple hundred miles from eastern California out here to the edge where it was the shoreline. And then the stuff was deposited in a delta. And then eventually the edge of the delta or shelf became unstable. And turbidite currents carried the debris down into the deep basin where it ended up. The other aspect of this, or another aspect is you can see there's sandstone beds in here that would also be turbidites. There should be some good graded bedding in some of this stuff, normal grading. You can see a contact up there that's kind of where the sandstone bed came in just after the conglomerate, and same back in here. Really nice area to look at deposition, depositional features. The other thing I like about this thing is how this face here on my hand is just clean. When the fracture broke across these rocks, it broke right through these clasts. These pretty sturdy clasts were broken right through here. And to me, that indicates that this cement in here, which is probably silica, must be very well indurated in here, and it's just a hard rock. Normally when you have a fracture or something like that, when it encounters something like cobbles, it wouldn't break right through the cobbles, but this one did, and it made this nice face. And there's several of these faces along here where it did the same thing. And there's one down there. It's kind of more rugged. There's another example over here where it just cut through the face, which I think is a good testimony, say, to the hardness of these rocks. And you can see some of these cobbles are quite big. They're really almost getting towards boulder size. Well, I'm on the Howard Creek Trail in the western Transverse Ranges. Beautiful day, and this video is getting a little long, so I'm going to stop it now.